Hi everyone, my name is Haley. I'll be going through a lot of the different slides and lead up kind of technical content today. I've been a machine learning solutions engineer here at Snorkel for I guess almost 5 or 6 months now. Before that, I was a similar kind of customer facing engineer at another MLOps company, and before that, a fully fledged data scientist and I guess AI researcher, mostly focused on medical imaging and things. But super excited to dive deeper today and kind of go through some of the technical content and then answer questions at the end. And Derek?
Yes. Hi, I am Derek Desjardins. So I'm a senior machine learning solutions engineer here at Snorkel. Um, and I guess I'm here because when my AI ML journey started a year or two ago, I recognized immediately that data was really the problem. And Snorkel came along and made sense to me and how it solved it. And I'm excited about delivering a demonstration to you today.
Awesome. Well, thanks both of you for that intro. And so, Haley, I think we'll have you take it away and look forward to having a great webinar today.
Perfect. Sounds great. So as some framing for what we'll be going through today, so I am going to start out with these first three sections and then hand it over to Derek to give the demonstration. But what I'm going to start out with is kind of why programmatic labeling, what's the motivation here, then go into an explanation, how does it really work, then some validation or a relatively small section, but some proof points and some quantitative results on how some of our clients are using Snorkel and kind of the value that comes from it. And then finally, the demonstration will be led by Derek at the very end to kind of see how it all works today. And so with that, let's start off with this motivation of why programmatic labeling. So for a very relatively rudimentary framework up front, but to make it really crystal clear, ultimately with AI, what we're trying to do is map some input to some output. So, given some situation data point, context, whatever it is, I want to attach a label or make a decision to extract a certain value, whatever that may be. And what I'm trying to do is essentially create a mapping from these inputs that I am looking over kind of all of the different data types we might be taking in and to gather those very specific outputs from them. And typically what we have here is an expert human who can do that job just fine. So they can make that decision given that data point, and they can select the right output most of the time. And really in practice, the goal that we have is to replace that expert human with an expert model. And so replacing or augmenting whatever that situation may be, but creating this expert model that can do the exact same mapping as our subject matter experts. And so what we're essentially trying to do then is at kind of this 10,000 foot view is transfer that domain knowledge from a human that would be making that decision to get into that model. And then the main question of AI development really becomes, how do I get this knowledge from my expert into this model that is ready to be deployed? And it's trustworthy and performant and all those other things that we also need when we kind of build out these production ready systems, especially in the enterprise. And so for a long time, and it's actually a lot of still what's happening most days today, the way of transferring that domain knowledge from human experts into this model is via the data. And so while many teams may still be doing some feature engineering or directly modifying the weights of a model, in practice, what teams have found is that the more data-centric approach of providing more or better training data is actually what is shown to make the model stronger or more production ready or performant. And from a lot of these different domain-specific and expert knowledge tasks. And so most of the time is actually spent creating this training data of point one or point two to understand whether that is training data for more generative tasks, augmenting your prompt or evaluating your retrieval pipeline, or even more predictive tasks of kind of extractive methods of understanding text classification or PDF extraction. Regardless, you are showing the model what you want to do via that data. And the likelihood approach of doing this is to take the manual approach of one by one, hand by hand, one at a time. And so here is the label for this document. Here's the label for this document. You can do that again and again and again, and with as many experts as you have access to. If multiple people can even kind of do it at the same time together, until you have enough data to teach your model what it really needs to know. And there are a number of issues to this and drawbacks that have been caused by this bottleneck in AI development, which is still the case today. So first is that it's a very slow process. A human has to spend time with each and every example, and the scaling process of that is not good. So it's very linear, and the curve is not necessarily that fast here. So dependent on the type of task, we've seen that some complex tasks, such as like underwriting, may take from 10 minutes to an hour per document to really understand and like flesh out the different labels that are coming in. Other ones might be lighter or faster tagging, but scaling wise, you're really looking at human time for each additional label that you want to bring into your system. Consequently, human time can be quite expensive. So you often need subject matter experts to give you their time, which we found they typically aren't very happy about. And then beyond even that, there is that opportunity cost associated with having them spend their day manually annotating or labeling data, especially because of our third point here, where the requirement of expertise for many generative or many enterprise AI systems. And so most of the real high value applications that enterprises care about are not really very trivial problems that anyone can help label. Instead, of having the ability for like more general type problems, like say like random strangers that could label things like, is this a cat or a dog, or is this a stop sign or not? Many enterprises are really anchoring on use cases for AI that require very business specific or domain concepts, and the understanding of your specific business needs to be informed on how to perform a task very well. Additionally, there are also privacy challenges, because if this data needs to be labeled by humans and you don't have that capacity to label that in-house, we've seen many teams often come up where they want to be like outsourcing or sending out their labelers to other options. However, many enterprises find that, especially with things such as like sensitive data that they might be using, whether that's healthcare data, financial data, or even just private data that the business doesn't want to risk getting out or having a leak or being on the front page of another data breach, many companies have gotten more keen into bringing these labeling efforts in-house, which moves a lot more labeling effects to be kind of put on to your own people or your own subject matter experts again, bringing them up against these potential blockers of like the slow, expensive, and like expertise required efforts of data labeling in-house. And then there's also an issue around adaptability. So if you're manually labeling data points and your needs change, say there's a new class or a new category that you want to label for, you would need to go back and manually relabel all of your original data points, kind of in that same manual one-to-one process. And because it was all manual before, there's really no way to run it back from the top without spending all of that time over again. We oftentimes call this kind of like a return to go method for not being able to adapt quickly to like changes that you might be seeing in production. And then finally, lastly, there is a governability question. So this matters increasingly as companies are wanting to make sure that they're not being sued for their AI, for it being biased, or for their data that they are for using data that they shouldn't be using, and relying on signals that maybe they shouldn't be using from like a compliance standpoint. So there are all sorts of reasons why companies would want processes that are repeatable and inspectable, rather than just kind of the process of, I don't know, that's the labels that they gave me, and so I used them. And so, which can like really expose different organizations to different levels of risk. And so with all of these kind of being taken into account, programmatic labeling was really born out of kind of focusing in on these different pain points that we just mentioned, and looking to find a way to make this annotation process more scalable and kind of address these problems at scale in an enterprise-ready way. And so what is programmatic labeling? Yes, Shane, you raised your hand. Oh, nope, no worries. So what is programmatic labeling? Programmatic labeling is an approach where labeling functions, which I'll introduce in just a second in the next section, help to encode knowledge, labeling functions, which help to encode knowledge, which is the expertise that we're trying to transfer, but we're finding a better way to do that. And they're used to programmatically label your training data at scale. And so essentially, you are able to then attach training labels to each of your data points with high quality at scale, which will be used to train your machine learning models. And so this process, you end up with these labeling functions that, yes, are faster and cheaper to kind of get this large scale amount of training data to like build out more high performant models, but they're also entirely reproducible. So kind of attaching into those other pain points that we saw before. In different ways, so they can, or we know that they will label it the exact way, the exact same way every single time. You can label as much data as you want. You can do it privately in-house, and this can be run in your own like VPN, so without exposing yourself to those different like data risks. And often, as you're able to do this iteration more quickly and more repeatably at scale and incorporate even more signals, what we're finding is with teams that they're able to yield much more higher quality models as well, like due to all of these different pieces as well. And so we'll jump more into programmatic labeling in a second, but to kind of start at its origins, where did programmatic labeling begin? So our founders began the Snorkel initiative around programmatic labeling about a decade ago now in the Stanford AI lab, beginning as an open source research project and then eventually kind of transforming into the company that exists today. And so really they did this looking at the industry and seeing a lot of the same trends that we're seeing in AI development almost a decade later, that hardware was becoming more and increasingly commoditized and available, that different models that teams were using were also becoming increasingly commoditized and available, and really that it is that data that makes the difference between high-performing and low-performing models, especially in business or domain-specific applications. And so in this area of data-centric AI, the team has published over 100 plus different research papers across a lot of different aspects of AI development, both predictive and generative. And so we'll dive deeper into some of the knowledge behind some of the original ones in programmatic labeling as well today. And all of this kind of research into the space and kind of experience that we've stacked up has led to a number of different findings. So today we're going to be focused on programmatic labeling in a more predictive realm, but there are other ways to do programmatic data development as well, like finding slices of your data set, sampling it, and distributing it so that it can be a better fit for what you care about, filtering out high quality examples, maybe to be used for like specific fine tunings and like tackling a specific error mode that you're looking for, and even augmenting with other like high quality examples that are curated to be similar to like the space that you're in or the examples that you're seeing. And so there's a lot of interesting and exciting things that are happening right now in the field. And while we're going to be focused on programmatic labeling specifically today, I did want to call out that these same programmatic principles kind of apply to a broader set of data operations than just the labeling. And so the goal really is the goal out of all of this is really to build out that systematic software-based process that can scale out with the enterprise and move away from a lot of the more manual or ad hoc labeling solutions of looking at data one at a time that exists in AI today. And so where is this used today? Lots of different places. So we've been fortunate that since the like more academic days of Snorkel, the team has been able to work with some of the most like ML forward organizations. We've also enjoyed working with a lot of the different like scientific and academic communities, especially in like the realm of medicine, as a lot of our founders kind of started in that space and definitely still enjoy working with it today. Then we're also taught in a number of different textbooks and courses in top universities. We definitely love them all and are a big Stanford hub, but I do have a soft spot for Wisconsin, so I'll call them out as they're on this slide. And then, of course, at the company now for the past few years, Snorkel has been working with a number of different Fortune 500 companies to really deploy this for direct enterprise use cases with good success. And so there will be a later slide where we can highlight some of the quantitative results as well, but just kind of calling out that, especially in these more domain-specific or like enterprise-heavy use cases that needed to scale out, is a lot of the places where Snorkel will play. And now that we've kind of done the high-level pain points that teams are kind of facing in AI development today, and then also a bit of the high-level pitch of what Snorkel is looking to solve. Now it's time to kind of get to the meat of it and really provide a bit of an explanation on how exactly does this programmatic labeling approach work, and how does it really drive forward these results that we'll talk about in just a second. And so one intuitive example that I find often helps people grasp what's going on here is to imagine that we're making a spam classifier. And you have a couple of spam emails, or really just a few emails at all. So it's like you kind of collected both spam and not spam. And you're wanting to identify which ones are spam and which ones are, we'll call it ham, but really like not spam, regular emails. And so one option we have is to read all of these ourselves and to make the call. And so if we kind of look at this slide here, it's pretty obvious that when we look at the ones that are in this spam email, why we would make this call that it's spam. I can put on my hat of a domain expert and say that I have the domain knowledge of having used the internet for a long period of time and being someone with an email account. I can kind of recognize that all sorts of things in this first email are pretty indicative of spam. And then if I were like an expert to be labeling these different data points, there are a couple of different things that I can do. One would be to have my reasons for labeling. So that's kind of this animation that I just struggled to put on the screen. But kind of like clicking through different examples here, we can see that this one for spam has a lot of different reasons on which why we would capture this like domain knowledge. And then things like whether or not like it's the formal greeting is like very formal and it's not personalized to me. There's things I don't recognize, like the domain, as well as a lot of typos and bad punctuations, and just really kind of like spammy email topics that are showing up, such as like these like sell or get rich quick schemes that tend to be in spam emails. And on the contrary, when we go into the valid emails, I can quickly pay attention to a lot of things that I understand, like it's addressed to me, as well as it's a valid email from someone that I recognize. It's someone I talk to often. The topic is relevant to other topics that I typically get in emails, and ... And so if I was an expert labeler, kind of labeling each of these data points, there's a couple of things I could do. One would be kind of giving these reasons I have for labeling, but or the first would be I kind of have these reasonings that I want to dive into for labeling, but maybe not giving each of them, but instead kind of clicking through all these different examples and like showcasing which ones are spam and which ones are ham, and then moving on to the next. And so then you can try and basically play this game of 20,000 questions with my machine learning model. And so it only kind of gets that feedback of like what is spam and what is not from me. And then eventually, hopefully, once I kind of create enough of those examples, it will be able to relearn some of the different reasons I had for labeling and kind of those correlations underneath the hood of like what is spam and what is not. And hopefully it does a good enough job with just the data that I'm able to kind of curate and show it. On the other hand, option 2 would be to capture that domain-specific knowledge more directly. So let these pieces of expertise that I have about the task get encoded into the software through this process of labeling functions. And so those will help provide additional sources of signal for why different data points are labeled different ways. And this will help me scale up my labeling so that for a single reason I can come up with why like this might be a spam email is now applied programmatically to millions of different emails. And that can do that in about a minute. And so then rather than however long it would take me to kind of go through all those emails myself and curate that larger training data set, I can programmatically apply the knowledge of all of these different functions to all of my unlabeled emails at scale very fast. And so thinking through what a labeling function could be. So basically what a labeling function is it's a way to codify your reasonings behind why you're labeling a data point a specific way into the form of a function. And so a labeling function can be as simple as a keyword or a regex-based example, like we saw in the last slide, or it can be more complex sources of signal, like connecting to your own knowledge bases or ontologies, Really anything that you can build out of the Python function can be made into a labeling function with our fully fledged Python SDK. And so this means that even more advanced techniques like embeddings or prompting machine or large language models can be used to label large portions of the data as well, which is a great way of capturing kind of those low-hanging fruit that can be handled out of the box before supplementing with other corrective labeling functions. And one of the key values of Snorkel is that each of these labeling functions that we create, or these rules or heuristics, really do not need to be perfect. So what Snorkel will do is it will take in all these different and often even conflicting sources of signal and denoise them into the correct probabilistic labels. And so this can be confusing when looking at labeling functions, as each is really built to tackle one aspect of heuristic of what makes something a particular label. And we can kind of take a deeper look underneath the hood on the next slide to really kind of understand what's happening. So here we can dive a bit deeper into what's happening. So it might be a bit lower level detail than what you really need, because in Snorkel, all of this is kind of happening underneath the hood with our label model. But ultimately, what is happening is that you're creating this matrix where each data point you're looking at is a different proposed label from different sources. And what we can have here is that these different phenomenon that show up. So sometimes you'll have labeling functions that are highly correlated, but not necessarily independent. So in these examples, you wouldn't want to double count what these two independent voters are doing. And then sometimes you might have labeling functions that totally disagree with others. That is a lower accuracy, and so maybe shouldn't be counted as often. And then other times, maybe what you have is a labeling function with lower coverage, but with very high accuracy. And so when it speaks, you really want to listen. It's almost not worth it if you have to manually compose all of these different aspects into a decision tree yourself. That would be very similar to almost like having to manually annotate all of the data itself anyway. And so at that point of hand constructing the classifier, that would be very difficult. And so like that is not what we do. Instead, what we do is we take all of these different sources of signals and we use what we call a label model, which is an algorithm that uses statistical information about these labeling patterns in the data to learn automatically and potentially fully unsupervised ways of when to trust which labeling function to statistically get the most likely results. So we're not going to dive too deep into detail here, as that can be found in a lot of our different research papers on both our older and more like newer and developed labeling models that we're building inside of Snorkel. But the idea basically is for a given situation, selecting the algorithm that's going to do the best job of combining those proposed votes. And so at the end of the day, what your process should look like is not having to construct this raw decision tree, but instead you dump in raw signals of varying accuracy and quality, and this will be solved mathematically to produce the confidence-weighted labels. And the nice thing about this is that you basically have continuous dials to help you trade off label quality and label volume for any given problem. So in an ideal world, you have high quality and high volume data. But now if you have sensitivity to either, you can explicitly control that instead of saying, say, like take it or leave it from what you can get from your human annotators. And I guess for one last like lower level dive into kind of what's happening under the hood and what you'll see from Derek, from more of a pipeline perspective to show you intuitively what is happening. Your labeling functions are labeling portions of your data typically, and so this will overlap in some areas and agree in others. This is ultimately resolved with the label models, which will help to create these confidence-weighted labels. And then eventually what you'll do is you'll train on whatever portion of those that you're confident about and get a model that we'll use to make the predictions on our end data. And so you can start off with these heuristics and labeling functions, but at the end of the day, you get a machine learning model to make the predictions in production. And so with that, you kind of get all the benefits of ML models, such as being able to generalize on new examples or data points that it is going to see in production, but may have not seen in training. And you might be wondering how this all relates to foundation models or LLMs. and which are quickly becoming more of a standard in NLP development. So there are a lot of places where they're relevant. Derek will highlight more of these in the demo, but all of this is to say that they've become a fantastic new tool in the toolbox to be used in a variety of different places. So whether that's as the final model that you're fine-tuning with the data that you're curating in Snorkel, or even as one source of signal to be fed into that label model and to be able to kind of label data more correct or at a very high level as kind of a jump start. And so this will all be more concrete as we dive into the demo after. But just then quickly to kind of orient ourselves on some of the different use cases and types that Snorkel Flow works on. So these programmatic data labeling is used in both predictive as generative, as I kind of mentioned before, but we support a wide variety of data types, focusing mostly on unstructured tasks. So you can think of things like text classification, PDF extraction, sequence tagging, entity recognition being a lot of those like very predictive use cases in which teams can kind of come up with reasons why they'd label something one way or the other and kind of do that codification for programmatic labeling. And then on the generative space, really kind of data labeling of a different name. So whether that is curating the like most high quality examples for fine tuning on what user preferences might be of accepted or rejected, like curating data to help fine tune an embedding model in a retrieval system, or even kind of scaling out evaluation for a lot of these different generative use cases is what we're finding a lot of different aspects of that as well. I guess then coming into the last step of the different like validation. So how well does programmatic labeling work kind of in the enterprise and in the real world? So here are just a few examples of global organizations that have benefited from programmatic labeling, really kind of value adding on a few core aspects. So the first is really that ability to get to production much faster with models, just due to that kind of bottleneck that exists of curating enough training data to get that high production value. The second one really being making better use of subject matter expert or domain expert time. And so with only a very small subset of manually annotated data, being able to scale out their domain-specific like expertise across the like models that you'll be able to build. So kind of a value add there. And then finally, this really that like adaptability and ability to like, kind of scale to more and more projects with Snorkel Flow. But we'll also talk more about that in the demo as well. So I guess throwing it over to Derek, who can come on screen now, who will help lead the demonstration and kind of make all of this a lot clearer by actually seeing programmatic labeling in practice.
Awesome. Thank you so much, Haley. Let me get my screen shared here. Okay. So thank you, Haley, for that awesome intro. So what is Snorkel Flow? Snorkel Flow is a unified environment where data scientists, subject matter experts, and even application developers collaborate to build high-quality model training data sets to improve, net is to improve the quality of your models in production. That's what we're trying to do here. So collaboration, error analysis, and annotation. This is a really important point to know, is that collaboration, error analysis, and annotation is executed on a very small subset of your data. You're going to see some examples here that are like 1% of the data or less. That's what we operate on. Okay, that creates a signal, which we then codify into, as Haley said, a labeling function, which then informs the label model, which explodes that across all of your data. Okay, this is the most important thing to remember. It's a very small amount of interaction with users, and the label model does the work. That's the whole idea. So the net result is scaling out your domain expertise and related resources with a software and machine learning approach, rather than manual and large rooms of people. So here at Snorkel, we clearly recognize that your data is the API to running quality domain specialized AI applications in production. So this is Snorkel Flow. So how do we work with your data in Snorkel Flow? In Snorkel Flow, we work with signals, right? And we use those to inform a label model, right? Just like you may use a model to answer questions from customers, we use a model to predict labels across your entire data set. These signals can come from structured or unstructured data via extraction spans, PDFs, cluster embeddings, and even responses from an LLM, which we'll show you today. So let's start with an oversimplified example. First, before we get into it, I want to just tell you what's on the screen. So this is Snorkel Flow. This is the user interface. This is the environment where people collaborate to achieve this. Okay. Obviously, there's a nav on the left. It's not important here, but I'm going to close it. I just wanted to point out it's there. These are the two panes. If you look at it, it's kind of like left and right. The right is a lot bigger than the left. What are they, right? So on the left side is your model building and guided error analysis. So that's when we apply the signals, build a model, report the results, and then tell you how to make it better. That's what the left side does. The right side is your content view. That's where you actually interact with the data itself, sampled data, right? So we sample a subset of the data for you so that you can interact with it and then build those signals or labeling functions, right? So we'll be interacting with both sides, but just a general idea of what's on the screen. Okay, so I'm going to start with a very oversimplified classification example. Okay, that's super, super simple. Okay, and right now we have, you'll see it on the right, we're going to focus on the right side. So if you guys can bring your eyes to the right, you see at the top we have patterns, prompts, and embeddings. I touched on that earlier. These are the ways that we create signal, right, in order to inform that label model that then explodes those labels across all your data. Okay, and we're going to start with patterns because it's simple. Now, in this case, we have a very simple data set. It's got a few thousand data points. You'll notice if you look on the right, and I think my cursor's over it, I'm circling it, we've sampled 377 records out of it that are basically just that text documents. And the idea here is we want to classify these text documents into one of 4 categories. What are the categories? I'm just going to show you the categories right there. Stock, loan, employment, and services. So this is the problem we're trying to solve. So option 1, get some subject matter experts and label 3,000 plus documents. Option 2, use Snorkel to build some signals off of a small subset of these, and then use our label model to apply it across the whole thing. Okay, so let's just start with a simple example. So how do I build one of these signals? So the first thing you do is we'll start with a simple pattern. So I go up here, and I get a drop down of all sorts of options and ways to kind of pull a chunk of text out of this document. I'm going to do a simple keyword just for the first one, and I'm going to put something in here that I know is in here. Obviously, it's a demo. Services agreement. So this is something that a subject matter expert may be like, oh yeah, I know that we have services agreement. That keyword text across our documents that would then identify those documents as services documents. Just to give you a kind of a colorful example of what a subject matter expert might do. So a subject matter expert could actually do this. It doesn't even have to be a data scientist in this case, right? It's pretty basic. So I go ahead and enter that. And then what I want to do is I know that the services agreement is a services, right? Is a services category. And then what I'm going to do is click this preview LF. And what that does, right, is then try to apply this keyword search across the data. And what it does is it gives us a result and see how accurate we are. So I'm going to go ahead and click that. And you'll notice the data is loading at the bottom, but I think what's most important here is the stats from it, right? So we see precision, our accuracy is pretty high, 90%. Our coverage is only 10%. So you might go, oh, wow, we have a lot more work to do. The answer is with Snorkel, you really don't. Even something just like this will get you a lot of bang for your time, if you will. So what I do next, okay, is then I click on Create LF. And what that does is that actually applies that signal or the labeling function to our model building area. So you'll see it pop over on the left. You can see it's coming in right now. I'm going to wait a second just so you see how this actually works. So now I have 2, right? And I have some coverage, right? But it's not covering everything. My accuracy isn't perfect. These things do not need to be perfect. It's like throwing stuff into the kitchen. It's like throwing ideas into the kitchen sink or on the whiteboard. It's like, oh, I know how to identify some of it. Boom, put it in as a signal or a labeling function. I know how to identify some more of it. Boom, put in another signal or labeling function. And then what do? You train the model and let the model do it for you, right? So I'm just going to do a fast model here just to show you guys how, and there's a lot more in this model dialogue. I'm not going to go into it right now. The point is to show you the loop of how people interact with this tool. And that's what's happening. So right now what's happening is those labeling functions are being applied to our label model. And then the label model is going to apply that data across the entire data set. That's what's happening behind the scenes and give us an accuracy readout. And you'll notice, you see, our accuracy went up. I'm not sure, I didn't point those out at the beginning, but they were much lower. And that is what you do. So 63% is probably not production level. So what do we do next? Guess what you do? You go over here and you do another one. So with that said, well, how do I, like, okay, great. I have all these documents. I built some signal. I trained a model. Like, what do I, like, where do I start? The answer is also on the left. So we have an error, we call it guided error analysis, a pane, if you will, right? Where it shows you various ways of looking at the errors and it tells you what to do next. So here at Snorkel, we love this thing called the clarity matrix, not to be confused with the confusion matrix, which I'll show you in a minute, which you may be more familiar with. But if you take a look at the red, right, we're looking at errors. Just take a look at the red on the left. It's really simple. There's some suggestions here. There are suggestions with numbers here, right? 2, 1, 34. Well, 34 is a bigger number, so I probably want to focus on where the biggest problem is. So you would go down here and click on write new labeling functions. The other way to look at this, so that's great. So it's like, okay, add more labeling functions, which you probably could have figured out. What I like to do also is to drill in another layer and take a look at the confusion matrix. And specifically, I like to look at it in a more tabular view like this and only show the errors. And what I like about this view that's really handy is it's telling us that the majority of the errors are in identifying the stock category and the loan category across the data set. And then guess what I would do? Click on the arrow, right? It then brings up a subset of data that was wrong in voting, right? You see how stock was the ground truth, employment was what was voted, so that was wrong. Now, basically, what I can do is create a new labeling function to fix that. Add it to the pile on the left, rerun the model, and repeat. That is the loop of Snorkel flow. Okay. All right. So let's we're going to take a pause for a second. Hopefully that you guys are digesting that information. Right. So again, it's interact with the right side, build a signal, add a labeling function, build a model, see what the errors are, and repeat. And you could probably see if you're sitting back and you're thinking about your own data, you could probably think about how when you're interacting with the right side, especially if you start getting into regex and all the more complicated things, how your data scientists and your SMEs would collaborate. All right, great. So let's move on to a more real world and current example. All righty. Just 1 second. All right, great. So we have an example here that is starting with an LLM. So another type of signal, right, other than just pattern matching in a document, would be the response from a large language model, right? Super common today. That's what a lot of people are using. And we could talk about, how accurate they are and all those things, and we will. But at the end of the day, they are super useful, and we use them here at Snorkel quite a bit because they're a great place to start when you're building something like this. So this application and this data set is quite a bit larger. You'll see there's actually about 13,000 records. Okay. This application is actually modeled after one of our customers, a top 10 US bank, which had over 500 classification categories they wish to apply to chatbot utterances, right? So people are chatting to the chatbot. I think we've all done that, right? We've all tried to probably talk to support chatbot from time to time, and we've probably had varying results. And obviously, people are trying to use AI to improve that. The challenge comes when you're really domain specific, right? They could tend to not be so accurate. When 1 minute they're talking about something financial, and the next minute they're talking about how to cook pizza or something like that. Okay. So what they quickly realized was that tinkering with or fine-tuning different models alone was not going to meet their accuracy needs over time. They realized that, well, like a lot of people do, the data really is the API to solve this problem. And that's what Snorkel does. So what is this you're seeing on the screen? What this is, right, is a prompt. So basically, if you take a look at what's going on here, right, so we've got First of all, let's talk about the model we're using. So we have a selection of models you could choose from, and you could use one after the other. So for example, if you wanted to create a signal from every single one of the models we have here, and even models you have yourself, we can do that as well, right? So all we're doing is using the LLM to ask it to categorize a bunch of text based on these 77 categories, okay? And then we're gonna get a response. That's all we're doing, right? And we can do it with model after model after model after model. And the loop is exactly what you saw in the previous example, right? It's exactly the same. Okay. So this data set has 13,000 unlabeled data points. We have only 300 ground truth or subject matter expert labeled data points, right? So it's a very small percentage. And that's what we typically work with, right? We don't need a lot to make this happen, right? It's a very, very small amount of ground truth we use, okay? So what I'm going to do is take this prompt and I'm going to run it over a sample of data, right? And I'm going to run it over about 1,000 records. So let's go ahead and do that. So basically what it's doing now is it's trying to answer the question. It's trying to say, what is the category of this text in all these 77 things? And obviously it's going to get some right, it's going to get some wrong, and we're going to see pretty quickly what we got. Oh, look, it did really well in this case on this small set of data. So this is a really good one to add, right? So we could actually take this prompt and then add it to our pile on the left and see how far along it goes. Oh, look, it's updating right now, so it's going to take a second. See, our precision went down just a little bit. Okay, so I think I'm going to jump to the next part because this might take a minute, but I think you guys are getting the idea. As soon as this is finished, right, and it's going to chug in a little bit. I don't want to have you guys wait for this though. What I would do is then click Create Prompt over here, just like I did before. It would add it to the pile on the right, and as you might imagine, I've already done this before, so we'll to speed up the presentation. So I'm going to go to a version of this, hopefully, yes, that already has this in. And I'll tell you that it's this entry right here. And you see that our final precision was only 67%. So that's what the LLM did out of the box, 67%, which is not enough to go to production. But we have some other levers here to play with. And let's go take a look at what we did. So let's see how many labels we generated, 11,682. And our best accuracy is at 60%. So we did go up a little in accuracy, but not a lot, but not enough. Okay. So the next step in this, right, so this is actually post-model build. So imagine, just to speed it up, I skipped a couple steps, but you saw them earlier. So we created the prompt, we added the prompt, we built the model, and guess where we go? Down to the clarity matrix to see what to do next. So we've got a few suggestions here. Refining existing labeling functions, refining our model, right? Changing a model, doing a different model. And let's talk about that. So how do we actually do that? So when we actually train our model, right, we have options here, and I glazed over them early on, right? And you could do a custom model that you provide, a bunch that we have, right? And you could use a whole bunch of different algorithms as well and models. So there's many ways to skin the cat. The point is that the clarity matrix is telling you where to go, right? It's not haphazard, right? You're not just guessing. Oh, should I make a labeling function? Should I build a model, right? Or try to swap out a model, or add new ones, or refine existing ones? It's going to tell you exactly where to go. And that's the most important thing here. Okay, which brings us to the next part. So I want to show you guys a little more detail down in the error analysis, and where I think with the LLM example, the confusion matrix really shines. So let's bring this guy up. All right, cool. Only show errors. All right, there we go. Okay. So we see a whole bunch of errors. So the next step here is, and let me make this a little bigger. So yeah. And we see where our errors are. Okay, awesome. So let's go ahead and click on one of these guys. Bring it up. Sorry, I'm having a screen issue. There we go. All right, great. So now what this is doing is bringing up, again, those error records to see, hey, what could we do to fix this, right? And we see here that in this case, getting the physical card is the ground truth, but what we predicted was change PIN. When we look at the actual data, the text behind it, it's kind of, you could understand why the model got it wrong, right? Can I create my own PIN right away? That's obviously referring to getting your card and not just changing your PIN, right? So there's the secondary or implied meaning to that, right? And that's where I could then go up and again, I could look for a certain pattern, right? I could rerun an LLM, maybe even another LLM or model on this, right? So another prompt. The other piece that I haven't showed you guys is embeddings, okay? And especially with LLMs, embeddings become increasingly important to be able to kind of tweak the levers of. All right, and here we go. Okay, so why are embeddings a challenge with LLMs out of the box? The reason is, it's kind of something I touched on earlier. An LLM will do a really good job of saying, if I have a bunch of questions around banking versus questions about how to cook a meal, it will be able to differentiate that very, very easily. What it may not be able to do, and most of the cases it can't, is differentiate amongst the financial questions, right? Which is, again, we're talking about domain-specific applications, and this is where LLMs fall short. The answer and how to solve that, right? I could play whack-a-mole with models all day, right? And it may be fun. Like, it costs a lot of money and it could take a long time. The data is the answer. You correct the data, you do it once and you're done, right? And you go forward. So one of the things is that we can tweak is the actual embeddings and how they're clustered. All right. So you'll see over here in our embeddings view, right, we have clusters, and I can click on these guys and show you different ones, right? And then we see suggested clusters that we suggest on the right side. And these, as you might guess, right, they also have a precision metric and a coverage metric, just like the patterns and the prompts. It's the exact same thing. It's just looking at the data from a different perspective, right? I could save this, and what it does is it adds it to my file on the left, right? So it's going to add it up here on the left, and that's what it's doing right here. And you can see it just did that. So I'm going to move on to the next part of this same application, okay? And you'll notice that here we've added a few more, and our accuracy's gone up a heck of a lot. And our label count has gone up a heck of a lot. The reason I'm showing you this, obviously in chunks, is just because we wouldn't have time to show you them, show you the build of every one. But the point of this is the repetitive process to label data with Snorkel, right? We label it on a very, very small subset of data, and then we explode it across all of your data using the signals or labeling functions, which we build into a model here on the left, right? And then how do you keep making it better? With the analysis tool on the bottom left as well. The last thing, I know we have a few more minutes left, and I wanted to leave room for questions. So I had one more thing I wanted to show you, and that is we get a lot of questions about PDFs, especially with RAG being such a thing today that everyone's doing. And we do a lot of work with PDFs. So I wanted to show you guys kind of just a little quick teaser, if you will, of how we actually parse and deal with PDFs. So PDFs we treat internally a lot like text, but we also recognize that there's an inherent structure to them. And just like when you're interacting with a pattern, right? You're doing a pattern, a prompt, or an embedding, you can do the same thing with PDF. But what's a little different really is the spans, right? The spans of the data. And you can see them all highlighted here in different colors. Each of these can be categorized themselves, right? So it's a span of data. Not only can you categorize them just on what the content is, but where it is, what's around it, right? Is it near an image, right? What words come after it, before it, all that type of stuff you can do with our PDF extraction technology. And then again, you're interacting with this the same way to create a signal as you would before. For example, okay, let's take a look at categories here. So you've got procedure, other, and unknown. So if I was going to try and identify something as a procedure here, right, I might look at physical exam, right? Here's a span. So you see the ground truth is procedure, right? And that's a good signal for me to look at. What I might want to do is actually just look for exam, right, in text. And you can see what's happening here. I'm going to select procedure, right? It's exactly the same thing. The only thing that's different is the data type, right? So this is actually a PDF data type. Oh, and it looks like I may have an error in my sorry, an error in my demo. But I think that will conclude the demo for today. And hopefully you guys learned a little bit about how Snorkel Flow handles your data, right? How it quickly can capture that domain expertise and label data across your entire data set. And I think we'll turn it over to questions.
Great. Thanks so much, Derek. And we'll have Haley come back on screen. And while we're waiting for Haley, just a couple of quick announcements. If folks are wondering, we will send out a recording of today's event, and there will be a survey when you exit today's webinar. We would greatly appreciate it if you'll provide your immediate feedback on the webinar. That helps us calibrate and provide content for future events. And one last quick announcement: on October 17th in New York City, we're going to have our first ever inaugural, I guess that's the same thing, first ever customer conference and open to the community. It's actually a free event called SnorkelCon, and I'll put a link here in the chat. So if anyone would like to join and register, you can register on our website at snorkel.ai/SnorkelCon, and we'd love to see you there. And on October 16th, the day before the conference, we're going to have live workshops as well in New York City. So there's a couple of different ways to engage and get deeper with Snorkel. So with that, let's jump into the Q&A. We've got a handful of minutes here for those. So there was a question that came in around kind of how much ground truth is required for the accuracy determinations. And maybe Haley or Derek, if you want to take that one. But I'll go to Haley first and see what she thinks.
I can tackle that one. And so, yeah, so Snorkel does require a very small subset of manually annotated data from the subject matter experts to kind of work twofold. So the first is as kind of like keeping in line with data science best practices, really that like training or like that test and validation data sets kind of curated by human annotators. And the second is to start to kind of guide forward those like feedback loops that you went through. So kind of even in some of the other questions that are like talking about like accuracy calculations and kind of like how we do that error guided analysis, really taking in that feedback there. And how much data like depends on the complexity of the task, both in terms of like how hard it will be to kind of train a machine learning model to understand the differences between the two different classes, as well as how many classes there are. We like, I don't know. I always make the joke that like I'm a data scientist, so as much data as you can give me, I'll take. But one of the values of Snorkel too is that like because we're a unified platform between data scientists and subject matter experts, you can start out with a smaller subsample of data than like you may eventually need. And so teams will start out with even like just like a dozens or even hundreds of examples for each of the different classes to kind of provide that starting source of signal. And then like as you're iterating through and finding areas where like your ground truth might be wrong, or it's been very difficult for you to kind of create a labeling function off of like different areas of the data, you can kind of send that back to your subject matter experts as a batch. And so really like keeping them in the loop for really the most only impactful slices of data that you want to look at.
Yeah, and I know for myself, it took me a little while to fully grasp that, but really is the magic in Snorkel is taking that subject matter expertise and encoding that into your AI models through the label model. And if you need to adjust classes or adjust things, you're able to do that programmatically versus having to send out to labelers. So while you do still need some ground truth, it ends up being quite a bit less and a lot more adaptive for production ML. We do have a question here just about the clarity matrix and just how it's created. I know as a Snorkel specific thing. So maybe Haley talk a little bit about the clarity matrix.
Yeah, I can tackle that one too. So the clarity matrix is like very Snorkel specific. So it's kind of looking at like not only guiding like where your errors are, but kind of where like you can best like iterate on those errors. So it kind of looks at different areas where the labeling functions you created were either potentially too noisy. So that kind of first bucket of maybe updating the labeling functions you have. So there, like it's a bucket where you're getting a lot of errors and you also have like some conflicting signals on your labeling function for like how those data points should be labeled. So in examples like that, maybe you have too broad of a labeling function that you might need to narrow down. So things like like one common example might be like all like topics of transfer. So it's like transfer might be too noisy of a word, and like maybe needing to like add in other segments to kind of narrow down like what is a pending transfer versus like a missing transfer. And then at the bottom of the clarity matrix, there's also like maybe you need to write new labeling functions. So that's like data points that your label is getting wrong, but you don't have any sources of signal to really kind of codify what those like data points should be. And so that's kind of an area where it's like maybe it like would be worth it to kind of invest in understanding those data points more and seeing if there are any trends in them. And then finally, in the middle bucket, we oftentimes see that as teams kind of iterate out, they're able to kind of iteratively correct those areas where they need to improve their labeling functions. But the middle bucket of errors is saying that your labeling functions are strong and they're correctly predicting or like giving the correct sources of signal for how the like what the different data point labels should be. But you might need a larger machine learning model to actually better generalize and kind of like take in all the different like framework points for even why sometimes teams will do that model-centric approach, even if they have like a lot of like human labeled data, really kind of like just a stronger machine learning model. And so kind of guiding teams that once you finish off that data-centric loop, there still is some like model-centric tweaks that you might do of kind of improving your model, changing your hyperparameters to get you to that production level accuracy.
Awesome. It's kind of a related question, and it's one that we get a lot just around, labeling functions, and it was hit on briefly, but what happens when two kind of labeling functions conflict?
Yeah. So what happens then is so the like really like value of Snorkel is our like label model that lives underneath the hood. And so with that, teams are able to kind of write off these different codified functions of what like good or bad might be or might not be, or like whatever they're trying to classify. And then kind of the first step of what happens in Snorkel is that those are denoised by our label model. So taking in kind of those different and oftentimes even conflicting sources of signal and denoising them into the correct probabilistic labels. So then ultimately the machine learning models that you build out will be based off of those probabilistic labels, which like we use weak supervision to like assure that they're the correct like high quality ones.
Awesome. Yeah, and I've heard it casually described as, kind of a jury. If we think about, all the members of a jury thinking about how to vote. And so it's a simple way to think about conflicting information coming in. Great. Well, I see we're coming up on the time here. So I do greatly appreciate it to everyone who stayed on, and we would love to see you either at SnorkelCon in New York City or an upcoming webinar or event. We do post all of those at snorkel.ai/events, and we have a weekly demo program that'll be picking back up after SnorkelCon in October. We cover a lot of generative demos there, RAG optimization, some fine tuning, chatbot. So definitely check out snorkel.ai/events. And again, thank you, Haley and Derek, for taking your time and presenting to the audience. If folks do have questions or you'd like to learn more about Snorkel Flow, you can always go to snorkel.ai and request a demo or contact the team. And with that, I'll let everyone say goodbye, and we'll end today's event.